To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. So I'm going to continue the chapter with some extra questions related to current electricity. In the previous chapter, we discussed the questions given in your textbook. So in this, there are extra questions. Extra question 1 contains MCQ type or multiple choice type questions. You're familiar with this type of questions? And I want you all to answer the question by yourself first, and then you can check your answer. You can compare your answer with my discussion. So then, the first question, extra question 1, select the most suitable answer. So why do they say select the most suitable answer? Sometimes you get the answer that is only one answer that is correct. Sometimes you get more than one answers that are correct, but out of those, one will be the most suitable answer. That is why it says select the most suitable answer. So then, the first question, charges generated by rubbing an object by another material is known as. So what do we do there? When you have an insulator material, you all know insulators usually don't allow current to pass through them easily. So they don't conduct electricity. Those are insulators. For example, wood, plastic, ebonite, glass, all those are insulators. So when you take these insulators and you rub them with another material, for example, ebonite rod rubbed with a polythene sheet or PVC pipe rubbed with a polythene sheet. When you do that, there are charges depositing on the surface of these objects. And that is what we call as static electricity. Why static electricity? Those are electrostatic charges and they do not flow. They do not move. They are stationary. That is why we call them as static charges, electrostatic charges. So if we look at the answers, current electricity. Current electricity, you all know, the charges that flow through a circuit or conductors is known as current electricity. Normally, electrons flow from negative to positive terminal of a dry cell through the circuit, whereas current, that is the conventional current, flows from positive to negative terminal through the circuit. So there it is the flow of charges. That is what we call as current electricity. Then static electricity, like I discussed, that is the charge that is present or seen or produced on the surface or deposited on the surface of an insulator material due to rubbing it with another material. That is static electricity. Then the third answer, electromagnetism. What is electromagnetism? Now you all might have seen when they want to transport cars, large vehicles which cannot move, or if they want to just transport it from one place to the other, sometimes they use a large iron plate like this, a circular iron slab connected to a crane. When that comes in contact with the car gets attached to that iron plate. How does that happen? There is electricity flowing through that iron plate, and because of that, the iron plate becomes a magnet. So due to the flow of electricity, if a material becomes magnetized, for example, an iron block or piece of iron becomes a magnet, that concept is known as electromagnetism. So at that point, we refer to that iron block as an electromagnet. So that is where we discuss electromagnetism. Then electromagnetic induction. What is electromagnetic induction? You might have seen this also sometimes. you make a coil of a conducting wire. Using a conducting wire, you make a coil and you connect it to a circuit, maybe with an ammeter, and then you take a permanent magnet and move that magnet into and out of that particular coil. Then you will see a deflection in the ammeter. So there is a coil which can conduct electricity. There is a magnet, so there is a magnetic field, and you are moving the magnet. When this magnetic field is undergoing a motion, a change, due to that there is a current induced. That is what we call as electromagnetic induction. So the answer suitable to the question, charges generated by rubbing an object by another material is known as static electricity. The second answer, static electricity. Then the second question. Consider the statements given below. A. Materials that allow current of electrons to pass through easily are known as conductors. That is correct. So, materials that allow current of electrons to pass through easily are known as conductors. Why? When current of electrons flow, like I told you all before, all matter are made up of atoms. Atoms have positively charged protons and negatively charged electrons. Electrons are present on the outer side of the atom, that is the shells. So these are the charged components that can move, that can flow. So because of that, when current of electrons flow from the negative terminal to the positive terminal, conventionally the current flows, electric current or conventional current flows from positive to negative terminal. So the materials that allow this electron to flow allow current to flow. So that is why materials that allow current of electrons to pass through easily are known as conductors. That is correct. Then, existence of free electrons is the reason for electricity to flow easily through metals. That is also correct. Why? Usually metals are very good conductors of electricity. And you all can remember in metals, what is the structure of metals if you look at it? If you take a metal rod like that, there are the positively charged nuclei, positively charged nucleus with the shells, and the electrons are usually in the form of an electron cloud. So these are the positively charged atoms. Why do they become positively charged? Because they tend to lose one or more electrons. And the electrons form a common cloud. And these electrons are free electrons. Now these are free electrons. Free electrons. In a metal, there are free electrons. So these free electrons can move very easily. They can flow easily when a potential difference is supplied across this metal. So that is why metals become very good conductors of electricity. So both the statements are correct. So answers, only A is correct, only B is correct, both A and B are correct, both A and B are incorrect. So it is the third answer, both A and B are correct. So materials that allow current of electrons to pass through easily are known as conductors, and existence of free electrons is the reason for electricity to flow easily through metals. Both the statements are correct. So with that, we will move on to the next question. Question number 3. The instrument used to measure electric current is known as. So what is the instrument? Now you all know for electric current, it is the ampere. Ampere is the standard unit. A. So The instrument is ammeter. You all know the quantities. They are standard unit that is used to measure the particular quantity and the instrument used. So for electric current, it is the ammeter. Unit is amperes. So voltmeter, what does that measure? Potential difference. Voltmeter, potential difference. These are things that you all know very well, students, but just to recall what you have already learned. Ammeter, current. Then what does the ohm meter measure? Ohm meter, resistance. Resistance. An electric motor. There actually electricity is converted to kinetic energy. The motor rotates and it is used in various devices. For example, a fan. The fan has to rotate. For that you need a motor, or a motor that is used to pump water. So in an electric motor, actually it is electricity converted to kinetic energy. Electric energy is converted to kinetic energy. So that is not an instrument used to measure a quantity. It is an electrical device. So voltmeter, potential difference, ammeter, current, ohm meter, resistance, and then we have electrical motor. So the instrument used to measure electric current is known as ammeter. You all need to know the spellings properly and also how we write. You can see voltmeter, ammeter, it's written together. But ohm meter, it's two words. Ohm meter. You don't write it together. You have to note down all those things. Right. Then question number 4. A factor that does not affect the resistance of a conductor. Does not affect the resistance of a conductor. So you all know the factors. One thing, cross-sectional area of the conductor. What happens if the cross-sectional area increases? The resistance decreases. So the current flow is easy. Then the length of the conductor. What happens when the length of the conductor increases? The resistance of the conductor also increases. So current flow will be difficult. Then the material composition of the conductor. For example, if you take copper, copper has less resistance. So it allows more current to flow through it. Whereas you take iron, iron has more resistance than copper. So it allows lesser current to flow through it. Then you are familiar with nichrome, an alloy made up of nickel and chromium that has high resistance. So it allows only a small amount of current to flow through it. At the same time, a larger part of the current is converted to heat. So that is why materials like nichrome are used as coils in equipments where we need to produce heat. For example, iron heaters, heating coils, we use nichrome. So that is the material that is used to make the conductor. And that property is known as resistivity of the material. So copper has less resistivity, nichrome has high resistivity. So 3 factors: cross-sectional area, length and resistivity. 3 factors. So a factor that does not affect the resistance. Cross-sectional area of the conductor, yes. Material of the conductor, yes. Length of the conductor, yes. Amount of current. That does not affect the resistance of the conductor. Amount of current, that does not affect the resistance of the conductor. In addition to that, you all can remember, students, the temperature also affects the resistance of the conductor. That is why when we do activity related to Ohm's law, we need to maintain the temperature constant. Because when temperature increases, the resistance of conductors will increase. So temperature also affects the resistance of a conductor. So here cross-sectional area, material length, in addition to that the temperature. You have to remember that as well. Then if we move on to the next question, that is question number 5. A conductor is connected to a power supply of 12 volt and the resistance of the conductor is 5 ohm. What is the current flowing through it? So here we have a conductor connected to a power supply 12 volt and resistance 5 ohm. You need to find current. So what is the equation? You use the equation for Ohm's law. V equals IR. I is equal to V over R, that is equal to V 12 volts and resistance 5 ohms. So 12 divided by 5. What is the value? 2.4 amperes. When you divide 12 by 5, you get the value 2.4 amperes. So if we look at the answers, 2.4 amperes, 60 amperes, 24 amperes, 0.4 amperes. We have calculated it as 2.4 amperes. That's the answer. Then the next one. What is the equivalent resistance of the system? So here they have shown the system. What is this connection? It is a parallel combination of 3 resistors. All 3 resistors are equal in value, 3 ohm resistors. So immediately you can remember. Without doing the calculation also you can find it. How? The same value, 3 resistors, parallel means the resistance will be divided by 3. So 3 ohm divided by 3, it should be 1 ohm. Like that you can quickly find the answer. But I will show you all the calculation also. So if the resistors are parallel, equivalent resistance equals 1 over R1 plus 1 over R2 plus 1 over R3. So that is 1 over 3 plus 1 over 3 plus 1 over 3. So all these together 3 over 3. When you take R, that is also 3 over 3. That is 1 ohm. Now can you all understand the shortcut method? If you were to answer the question, you have to write and show this calculation. But like I said, for an MCQ, you look at the combination, parallel combination, and all the resistors are equal. You divide the resistance of one resistor by the number of resistors. So 3 divided by 3, 1 ohm. That is something you get from this equation, student. So if you want to do the calculation, it's fine. But if you are used to the method of calculating with this shortcut method, you can divide it by 3. But you have to look at it carefully. All the resistors are equal, 3 ohm, 3 ohm, 3 ohm. And it is parallel. Then you divide the resistance by the number of resistors. So that is a shortcut method. Resistance divided by number of resistors. This is something you can note down. Then here, what is the equivalent resistance of the system? 9 ohm, 1 over 3 ohm, 1 ohm and 3 ohm. So equivalent resistance is 1 ohm. I'm sure you all can understand this and you would have done it correctly also. So with that, I'm going to move on to the next slide. Question number 7. There is flow of electrons when two materials are rubbed together. What will happen when the material loses electrons? This is something you all know very well. Now when you have an atom, when you have a material, they are made up of atoms. atoms have equal number of positively charged protons and negatively charged electrons. So that is why atoms are electrically neutral. But when you rub a particular object with another material, there is transfer of electrons. When electrons flow from one object to the other, the object that loses the electrons gets positively charged, and the object that gains the electrons becomes negatively charged. So here, if you have two objects and electrons go from here to here, then of course this will become positively charged, that will become negatively charged. Say if this is one object and this is a cotton material or sheet of polythene. So when you rub it, if the electrons flow from the object to the material, then object gets positively charged, material gets negatively charged. So that is how it happens. There is a flow of electrons when two materials are rubbed together. What will happen when the material loses electrons? The object will become positively charged. So it becomes positively charged, it becomes negatively charged, it becomes positively or negatively charged. It doesn't become positively or negatively charged. So what will happen when the material loses electrons? It becomes positively charged. Why? It loses electrons. So this particular thing, it becomes positively charged. Right. So then the next question. Question number 8. The circuit symbol of variable resistors. Variable resistors. Now you can remember there are two symbols for resistors. One is a zigzag line, the other one is a rectangle. And that is for fixed resistors. If you put an arrow across it, it becomes the variable resistor. So we'll look at the symbols. Now this one, zigzag one, fixed value resistor. Fixed value resistor. Both these are fixed value resistor, either this symbol or the rectangle symbol. Now when you have the same symbol with this arrow across it or this symbol with an arrow across it, that is for a variable resistor. For variable resistor, it is this one. Then the last one. Here you can see circle and the letter capital A. What does that symbolize? An ammeter. So this is for an ammeter. The first two symbols are fixed value resistors, third one variable resistor, and fourth one ammeter. And the answer for the question is the third one. I'm sure you all also answered these correctly. So with that, students, we'll move on to the next slide. Question number 9. The correct plot of potential difference against current according to Ohm's law. So Ohm's law, what is the relationship? At constant temperature, the potential difference is directly proportional to current. So from that, we arrange it as an equation. V over I is equal to a constant, and the constant is known as the resistance R. So for that, if you plot the graph against potential difference and current, it has to be a straight line going through the center of origin. So if you look at the graphs, this is a straight line going through the point of origin. This is a curve, that is also a curve, that is again a curve. So then only correct answer is the first one. And if you take the gradient of the graph, you will get the value of resistance. Why? V divided by I will give you resistance. So if you look at it also in a mathematical way, V equals IR. This is like Y equals MX. So here it is actually I is X and R is M. So you get the gradient M, that is the resistance of the conductor. So the correct answer is going to be the first answer. The correct plot of potential difference against current according to Ohm's law. This is the plot. Then the 10th question. Select the correct statement. So here you have to select the correct statement. Both electrons and conventional current flows from negative to positive terminal. So if you are to consider the current flow, what happens there? You have a circuit like that. If you have a bulb, you have a power source, positive, negative. Now how does electron flow? Here electrons flow from negative to positive terminal. They flow from negative to positive terminal. Whereas the current I flows from positive to negative terminal. So positive to terminal current flow, negative to positive terminal electron flow. That is what happens in a circuit. I'm sure you all know this very clearly. So if we look at the answers, both electrons and conventional current flows from negative to positive terminal. No. Both electrons and conventional current flows from positive to negative terminal. That is also incorrect. Electrons flow from negative to positive terminal, while the conventional current flows from positive to negative terminal. That is correct. Electrons flow from negative to positive terminal, while the conventional current flows from positive to negative terminal. Fourth answer, both electrons and conventional current can flow in any direction depending on how the cells are connected. No. You have to connect the cells in the correct manner. If there are more than one cells, you all know that for a potential difference to exist, positive, negative, then the positive terminal of the second battery, negative, like that, it has to be connected in the correct manner. And also, whether there is one cell or more than one cells, when they are connected properly and the circuit is completed, always electrons flow from negative to positive terminal, while current flows from positive to negative terminal. That is how it happens. So the third answer. With that, students, we'll move on to the next slide. Question number 11. The current flowing through a conductor is 5 amperes and the resistance of the conductor is 10 ohms. What is the potential difference across the conductor? So, the values are given to us 5 ampere and 10 ohms. What is the equation? We need to find the potential difference. So, V equals I R. I is given to us 5 amperes and R is given to us as 10 ohms. So 5 into 10, 50 volts. That is the potential difference or voltage. So the answers are there. 50 volt, 2 volt, 0.2 volt, 10 volt. So the correct answer is 50 volt. We have calculated the value. You use the equation V equals IR. I is 5 amperes. R is 10 ohms. So 50 volts. Then Question number 12. Correct statement regarding the resistance of the conductor. So, two things. One thing, correct statement, then the resistance of the conductor. That is what you have to concentrate. Resistance decreases when the temperature of the conductor increases. That is wrong. I told you all before also, there are factors. The temperature affects the resistance of a conductor. When temperature increases, resistance increases. That is why when we did the activity to observe the relationship between potential difference and current, or to illustrate the Ohm's law, you have to maintain the temperature constant. And also when we derive the Ohm's law also, you can remember at constant temperature, potential difference is directly proportional to current flow. And when you divide potential over current flow, you get the resistance, and that is a constant at constant temperature. So if temperature changes or temperature increases, the resistance increases. So resistance decreases when the temperature of the conductor increases. It's wrong. Then there are the other three factors. Cross-sectional area of the conductor. When that increases, resistance decreases. When the length of conductor increases, resistance increases. Then the resistivity depends on the material of the conductor. Again, you all know materials like copper has low resistivity, so low resistance, compared to materials like nichrome, which has a high resistivity, therefore a high resistance. So those are the factors. The second one, resistance decreases when the length of the conductor increases. That is also wrong. First one wrong, second one wrong. Then third one, resistance decreases when the cross-sectional area of the conductor increases. That is correct. Resistance does not depend on the specific resistance of a conductor. That is also wrong. When we say specific resistance, that is resistivity. So here, specific resistance means resistivity. It refers to the same thing. Specific resistance and resistivity are the same. So resistance does not depend on the specific resistance of a conductor. That is also wrong. Why? It does depend. That is why it depends on the material of the conductor. So the correct statement is that resistance decreases when the cross-sectional area of the conductor increases. When cross-sectional area increases, resistance decreases. So that is the answer for the 12th question. With that, we'll move on to the next question. Question number 30. Incorrect statement regarding Ohm's law. So, incorrect statement regarding Ohm's law. What is Ohm's law? At constant temperature, the potential difference is directly proportional to current. So, from that, we get the equation. You all can remember. So, we have V proportional to I. Therefore, V over I is a constant. And that constant is what we call as resistance of the conductor. From that, we get the equation V equals IR. That is the equation for Ohm's law. So, this is what is the Ohm's law at constant temperature. So then, the first one. The current passing through a conductor is inversely proportional to the potential difference at constant temperature. That is wrong, because here it is directly proportional. Second answer, the ratio between potential difference and current flowing through a conductor is a constant. That is correct. That is this one. Then, the gradient of the plot between potential difference and current gives the resistance of the conductor. That is also correct. We looked at the plot. We have a plot like this, where you have potential difference and current, and the plot will be like this. And if you find the gradient, that is equal to resistance. So this is the gradient resistance. The second statement is correct. The third statement is also correct. Then at constant temperature, the current flowing through the conductor increases when the potential difference increases. That is correct, no? Potential difference is directly proportional to current at constant temperature. So when the temperature is constant, current flow will increase if the potential difference increases. So that is also correct. That means the incorrect statement regarding Ohm's law is the first one. The current passing through a conductor is inversely proportional to the potential difference at constant temperature. That is the incorrect statement. So these are all the information related to Ohm's law. Then the next question. Question number 14. The correct plot for voltage difference against current according to Ohm's law. In the previous question also, we came across this. So you know the plot. Potential difference against current, this is a wrong one. It has to be a plot going through the center of origin, a straight line. This is a curve and this is the correct one. This is also a curve. So this is the plot that is relevant, the correct plot for voltage difference against current according to Ohm's law. The third one. Then, if we move on to the 15th question. The current flowing through the resistor of 12 ohm. So there we need to look at the circuit. Here you can see this is a parallel combination of resistors 6 ohm and 12 ohm. So what will happen? The potential difference across these 2 points is the same, 12 volts, but the current, here it is I, here it is going to be I1, this is going to be I2. Current will be divided according to the resistors. More current through less resistor, less current through more resistor. So we need to find the current flowing through the 12 ohm resistor. Then we can directly use the equation V equals IR. I is equal to V over R. Here the potential difference is the same, 12 volt for both the resistors. Then the resistance is 12 ohms. So directly we can apply the Ohm's law for that particular resistor only. Here you don't have to calculate the total current and then divide it among the resistors. You consider only that resistor, the potential difference, and use this equation. So 12 volt divided by 12 ohm, 1 ampere. That is the current flowing through the resistor 12 ohms. So the total current will be greater than that because part of that current only is 1 ampere. There will be more current flowing through 6 ohm resistor. And you can remember there is a ratio. Here the ratio is resistance 6 is to 12. So 1 is to 2. Current will be 2 is to 1. You can just recall what we learned before. So you can understand that there will be a 2 ampere current flowing through the 6 ohm resistor as well. When you all answer questions like these, students, try to recall what you have learned in addition to the question as well. Then it is more better for you all to study. But for this question, we need to find the current flowing through the 12 ohm resistor. So I equals V over R, 12 volt divided by 12 ohm, 1 ampere. So the answer is going to be 3 ampere, 2 ampere, 1 ampere, 4 ampere. So 1 ampere is the answer. Then 16th question, incorrect statement regarding series combination of resistors. Incorrect statement regarding series combination of resistors. So when there is a series combination, what happens to the equivalent resistance? Equivalent resistance is equal to the sum of the individual resistors. So the equivalent resistance will be greater than the individual resistors. The same current passes through all the resistors. That is also correct. So if we use a diagram, so here if you have a series combination like that and potential difference R1, R2, so there will be a current flow I. The same current will flow through both the resistors because it is a series combination, but the potential difference will be divided between the resistors. So here the potential difference will be V1, here the potential difference will be V2. So V1 and V2 together will be equal to the potential difference of the power supply. Is that clear? So these are the information that you already know. So based on this, you answer the question. The same current passes through all the resistors. That is correct. That is correct. The sum of the potential differences across the resistors is equal to the supply voltage difference. That is this. Sum of the potential differences across the resistors is equal to the supply voltage difference. That is also correct. Then the third one. The equivalent resistance is equal to the sum of all the resistors. That is also correct, no? Now equivalent resistance is what? If you take it as R is equal to R1 plus R2. So equivalent resistance is equal to the sum of all the resistors. That is also correct. So this is also correct. Then the last one, the same current does not pass through all the resistors. That is incorrect. The same current passes through all the resistors. That is the important thing. The same current does not pass through all the resistors is wrong. It is an incorrect statement because the same current passes through the resistors. The same current. I am sure you all can understand that. So the answer for this question, incorrect statement regarding series combination of resistors is that the same current does not pass through all the resistors. Okay. With that, I'll move on to the next question. Question number 17. Find the value of the resistor. So here, you're familiar with this diagram. You all know this is a fixed value resistor with color bands. Now here in this diagram, there are only 3 color bands. You are used to 4 color bands, and out of those 4 color bands, when you look at the resistor in such a way that the 3 color bands are close to each other and the 4th one is a little far away, and the first 3 should be on your left hand side. You start reading from this side, left to right. So you can see the colors red, black and brown. And you all know there are values. So this is the tens place, this is the 1 place, and then you have the index to the power of 10. Those are the color bands, 3 bands. Then you know to find the value. Now red color, if you look at the table, color and the values are given. Black 0, brown 1, red 2. So red color band, the value is 2. It is the tens place. So you write the value 2 there. Then you have black. Black, what is the value? 0. So you put the value 0, ones place. So 0 there. Then we have brown. Now brown has the value 1, but the third band corresponds to 10 to the power of 1. Index to the 10th power. So 10 to the power of 1 is what? 10. That means there should be one more 0 added to it. So here the value is 1. You need to add one more 0. So the value of this resistor, red is 2, black is 0, and then brown 1. But the third one is the index of 10th power. So you put 1, 0. So the resistance becomes 200 ohms. So if you look at the answers, 210 ohms, 201 ohm, 211 ohms, 200 ohms. So the answer is 200 ohms. Red, black, brown. Is that clear to you? So that is how we find the value of the resistor using the color bands, color code. 18th question. Combination of resistors with an equivalent resistance equal to 10 ohm. So you need to find the proper combination that gives an equivalent resistance of 10 ohm. Now if you look at the first diagram, figure A, 5 ohm plus 5 ohm, immediately you know it is a series combination. The resistance gets added up. So 5 plus 5, 10 ohms. If you take this one, what is the resistance? 1 over R is equal to 1 over 20 plus 1 over 10. So that is going to be 1 over 20 plus 2 over 20. That will be 3 over 20. When you take the reciprocal, R will be 20 divided by 3. From here, R is going to be 20 divided by 3. That's not equal to 10 ohm. Then look at this one. Again 20 and 10 ohm. The resistance is 20 by 3. And 5 ohm. So that is also not going to be equal to 10 ohms. Because this part is same as this. So the equivalent resistance of this component is same as this 20 by 3. That is why 20 by 3. Then the 5 ohm resistor is in series to that. So 20 by 3 plus 5. That is not equal to 10. So it's only the first combination. Series combination of two 5 ohm resistors that will give you an equivalent resistance of 10 ohms. So the answer will be combination of resistors with an equivalent resistance equal to 10 ohm is only A. A and B, B and C, A and C. Those are not correct. It is only A. So I am sure students, you all also did these two calculations correctly. So with that, I will move on to the next question. Question number 19. Again, find the value of the resistor. So to find the value of the resistor, like I told you all before, this is a resistor with color bands, the color code. So color code means each color has a corresponding value, yellow 4, orange 3 and red 2. So you have to look at the resistor so that the 3 color bands that are close to each other comes to your left side. You start reading from the left side and normally there will be 4 color bands. the fourth color band will be slightly far away. That is to calculate the tolerance level. But here only the first three color bands are given, so that we need to find the value of the resistor only. So how do you find it? First band is the tens place. You look at the number corresponding to the color yellow 4. You write the value 4 there. Then the second band, you can see orange color. Orange color 3. So that is the ones place. You write that 3 also here. So first one write the value 4. Second one write the value 3. Then the third color band is the index to the 10th power. Red color. So red means 2. So that means 10 to the power of 2, that is 100. You need to add 2 zeros there. So here you need to add 2 zeros. Red value 2, you add 2 zeros. Is that clear? Write the first value, yellow color 4. Second color orange 3, you write the value. Third color red 2 means 2 zeros. So 4300, that is 4300 ohm. That is the value of the resistor. 432 ohms, 4300 ohms, 430 ohms, 234 ohms. The answer is 4300 ohms. Then the 20th question. Standard unit of measuring potential difference. What is the standard unit of measuring potential difference? Volts. V, capital V. We use the voltmeter. That is why we call it as voltage difference also. So standard unit of measuring potential difference is volts. If we look at the answers, this is ohm. Ohm is for what? Ohm, resistance. Volt, potential difference. A, amperes. Amperes for current. And J, joules. Joules for what? Normally we use joules to measure energy, work done. So you are familiar with that as well. Energy, work done. Those are measured in joules. So the answer here is volts. Volts. Volts is for potential difference or voltage. That is the answer. Standard unit of measuring potential difference is volts. Then the next question. In light-dependent resistors, what are light-dependent resistors? Resistors in which the resistance depends on the intensity of light. When the light intensity is very, very less, the resistance is high. That is, in the dark, when there is less light falling on the resistor, the resistance is very high. During daytime, or otherwise, if you can shine light onto the LDR, light dependent resistor, then the intensity of light will increase. Then, of course, the resistance will decrease. That is how the LDR functions, light dependent resistor. So, in light dependent resistors, resistance is high during daytime when intensity of light is high. That is wrong. Resistance is low in the dark when light intensity is low. That is also wrong. Resistance does not change with the intensity of light. That is of course wrong, because these are light dependent resistors. LDR, light dependent resistor. The fourth one, resistance decreases when the light intensity increases. That is correct. So we need to find the correct one. Resistance decreases when the light intensity increases. That is correct regarding light dependent resistors, LDR. Then 22. The figure that shows the combination of resistors with an equivalent resistance of 4 ohm between points A and B. So we need to find the equivalent resistance as 4 ohms. If the resistance of the circuit is equal to that, then that is the correct figure. So let's look at the first one. Now first one, 1 ohm, 5 ohm, they are in a series combination. Then we have 12 ohms here. So 1 ohm and 5 ohm, 1 plus 5, you get 6 ohms there. So here it's going to be 6 ohm. Then 6 ohm and 12 ohm are in a parallel combination. So how do you find that there? Then you find the equivalent resistance 1 over R equals 1 over 6 plus 1 over 12. So here you have to take the least common multiple, 12. So this becomes 2 plus 1, that is equal to 3 over 12. So therefore R is equal to 12 by 3. That is equal to 4 ohms. So for the first one, equivalent resistance is equal to 4 ohms. I'm sure you can understand the calculation. If you look at 1 ohm and 5 ohm, series combination. So sum of the resistors, 1 plus 5, 6 ohms. Then this and this, they are parallel. So 1 over R, 1 over 6 plus 1 over 12. You take the least common multiple, 12. So this becomes 2 because 6 times 2 is 12. So 1 into 2, 2 plus 1, 3 by 12. So if you find R, it is equal to 12 divided by 3, 4 ohms. That is the same equivalent resistance. Then if you look at the next one, just to check whether the others are correct or wrong. So we will calculate the equivalent resistance here. 1 ohm, 5 ohm and 12 ohm resistors, they are connected in a parallel combination. So how do you find it? 1 over R is equal to 1 over 1 plus 1 over 5 plus 1 over 12. So here you need to get the least common multiple, 1, 5 and 12. So it has to be the multiple of 5 and 12. So that will become 60 over. So here 1 into 60. It will be 60 plus 5 times 12 is 60. So 12 plus 5. 5 times 12. So it's 5. Then it's going to be 72, 77 over 60. Then R will be equal to 60 over 77. Then you know it is less than 1. 60 divided by 77. So that circuit is not relevant or it doesn't have an equivalent resistance of 4 ohms. Then you look at the third one. This is again like a practice, students. We are doing the calculation, so you all know it easily. I'll use a different color, yeah. So here again you can see 1 ohm and 12 ohm series combination. So 1 plus 12, you have 13 ohm resistance there. Then 5 ohm is parallel to that. So to calculate the equivalent resistance, 1 over R equals 1 over 13 plus 1 over 5. So here also you multiply 13 into 5. So that is going to be 65. So this has to be 5 times plus 13 times 18 over 65. But when you calculate R, it is going to be 65 divided by 18. Then 65 divided by 18, but it is not going to be 4 because 4 times 18 is going to be 72. So that is less than 4. So this also does not have an equivalent resistance of 4 ohms. Then look at the fourth one. last one. Here again we have this particular one, 5 ohm and 12 ohm. They have an equivalent resistance of 17 ohm, then 1 ohm. So if you are to calculate the equivalent resistance of the system, 1 over R, 1 over 17 plus 1 over 1. So that will be 17, 1 plus 17. So that's going to be 18 over 17. So if you calculate R, it is going to be 17 divided by 18. That is less than 1. So that is also not equal to 4. So if we look at all the calculations. Now here the first circuit has an equivalent resistance of 4 ohms. That is our question also. So here the answer is the first one. But we did calculate all the other equivalent resistances, but I didn't go to get the decimal values because from the value you can see they are not equal to 4 ohms. So this is the circuit, the figure that shows the combination of resistors with an equivalent resistance of 4 ohms between points A and B. I am sure you can understand this clearly. So with that, students, I will move on to the next question. 23. 3 identical conducting wires of same length were taken. The full length of conductor is used in the first circuit. So here if you look at the circuit, this is the conductor. Full length is used. Then there is a power source with a potential difference of 6 volts and there is a light bulb. In the second circuit, the conductor was divided into 2 equal parts. So here it has been divided into 2 equal parts. And in the third circuit, the conductor was divided into 3 equal parts as shown in the figure below. 3 equal parts. The voltage of the battery is the same in all 3 circuits. So all 3 have 6 volts, 6 volts, 6 volts. Circuit 1, 2 and 3. In all 3 there is the bulb also. So you can see that. The bulb that lights with the highest brightness. So here important thing, highest brightness. Now how do we find that? Now you know resistance depends on length. What happens when the length decreases? Resistance also decreases. So in the first circuit, it is the full length. Then we divide it into half. So if the length is L, then we have L by 2, then we have L by 3. So if you consider the resistors individually, L will have more resistance than compared to L by 2, half the length. And that will have more resistance when compared to L over 3. So from that itself you can see circuit 1, 1 resistor with the length L. Circuit 2, 2 resistors with the length L by 2. And circuit 3, 3 resistors with L by 3. That is one thing. Then the second point you have to consider is this. Now here see there is only one resistor. Here there are 2 resistors connected parallelly. Now you know when you connect the resistors parallelly, what happens? If they have equal resistance, depending on the number of resistors, the resistance gets divided further. So already in the second circuit, L became half. So the resistance also becomes half. But again there are 2 resistors like that. That has to be again divided by 2. So it becomes resistance divided by 4. But if you take the third circuit, already the length is divided by 3 times for each conducting wire. The resistance also gets divided by 3 times. But then again, there are 3 resistors parallel to each other. That also decreases the equivalent resistance by 1 over 3. Therefore, in the third circuit, the resistance will be the lowest value. So here, one thing you have to remember, when the length decreases, resistance decreases. Then in parallel connection, parallel combination, the equivalent resistance decreases. So there, if it is 2 resistors with equal value, then it becomes R by 2. If you have 3 resistors with equal value, then it becomes R by 3. So either way, if you take the third one, where you break or cut the conducting wire into 3 pieces, already the resistance decreases by 3 times, and also due to the parallel combination also it decreases by 3 times. So that means overall the third circuit has the lowest resistance. So now look at the circuits here. Full length of the conductor. Conductor divided into 2 halves, conductor divided into 3 halves and connected in a parallel manner. So the circuit with the least equivalent resistance. Equivalent resistance. So then the bulb will be the brightest there. This will have the lowest brightness, this will have the moderate brightness, and there it will be the highest brightness. So the circuit with the highest brightness is going to be the third circuit. Circuit 1, circuit 2, circuit 3, and in both circuits 2 and 3. It has to be circuit 3 with the highest brightness. Is that clear to your students? So when you look at it, you have to consider the fact that the length of the conductor decreases. So that leads to decrease in resistance. And then when you have parallel connections also, the equivalent resistance decreases. So because of that, overall, the third circuit has less equivalent resistance. Therefore, the current flow is the highest and the brightness is the highest. I am sure you all can understand that, students. So with that, I will move on to the next question. 24. There the diagram is given on top. What is the current flowing through the circuit? So here you need to find the current. Now look at the circuit. We have a 6 volt power supply. So from plus to minus current flow, then 18 ohms, 18 ohms. So they are connected parallelly. Now that you are familiar with this, you immediately know the equivalent resistance is going to be 18 divided by 2 by 2 equal resistors. So you divide it by 2, that will become 9 ohms. Is that clear? Even if you do the calculation, 1 over 18, 1 over 18, 2 over 18. So when you get the reciprocal, you get it as 18 over 2. So that is the equivalent resistance. Then to calculate current, V equals IR, I is equal to V over R, and that is equal to potential difference 6 volts, and R is equal to 9 ohms. That is 2 over 3. If you simplify, 2 over 3 amperes. Then you can look at the answer. Then you can decide whether you need to divide and get the decimal value or not. Here if you look at the answer, it's given as fraction. So 2 over 3 amperes. So what is the current flowing through the circuit? 1 over 6 amperes, 2 over 3 amperes, 3 amperes, 6 amperes. The correct answer is 2 over 3 amperes. Is that clear to you all, students? So first, look at the circuit. It is important. There are two resistors, equal values, 18 ohm, 18 ohm. And they are connected parallelly. So you know the equivalent resistance will be half of the individual resistor. So that is 18 divided by 2, 9 ohms. Then to find current flow, you have to rearrange the Ohm's law equation. I equals V over R. V is given as 6 volts. We calculated the equivalent resistance 9 ohm. So 6 divided by 9, 2 by 3 amperes. 2 over 3. That is the answer there. Then we will move on to the last MCQ of this chapter. 25. What is the potential difference between the terminals of the 6 ohm resistors? So look at the circuit. You have a 12 ohm resistor, another 12 ohm resistor, here another 6 ohm resistor. Potential difference 12 ohms. Now these two are parallel. So what is the equivalence resistance there? R is equal to 12 divided by 2. Why equal values? 2 resistors. So 12 divided by 2. 6 ohms. So this part is 6 ohms. And here you have another 6 ohms. Again, those are two equal resistors. Then what will happen to the potential difference? That also gets divided equally. Why? 6 is to 6, 1 is to 1. So therefore, the 12 volt gets divided equally. So here 6 volt is between these 2 points and 6 volts between these 2 points across the 2 components. So there. What is the potential difference between the terminals of the 6 ohm resistor? That is going to be 6 volts. 6 volts. Because the equivalent resistance of the two parallel resistors is equal to 6 and that is equal to the 6 ohm resistor, the potential difference gets divided equally. That is what you have to remember. So there the potential difference across the 6 ohm resistor is 6 volts. Is that clear, student? So with that question, students, I am going to end this chapter. I am sure you all were also able to answer these questions clearly and correctly. And you all got a better understanding of the lesson. So then in the next chapter, I will discuss some questions where you need to answer the questions. You need to write the answers.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.